millennium, we started programming computers, and it became pretty clear we needed tools like automated testing. It wasn't until this millennium when our Agile teams really got into looking at testing and looking at how we automate testing and deciding, you know what, we need some structure here. Hence the test automation pyramid. So with the pyramid, it really is the beginnings of us having an architecture for test automation. Have those foundational tests and building layers of testing on top of those foundational tests. So the idea of foundations and building on them. Simple architecture going on. Well, what is the most foundational level of testing that we need to worry about? Unit testing. But that leaves unanswered, what is unit testing? Jez Humble actually is very, very specific about what unit testing should be. True unit testing. And what he's referring to here is not testing that unit in the context of the whole system, but testing it by itself. Why would we want to do that? Because really what we're trying to achieve with unit testing is actually running every line of code. And when you have the unit in the entire system, that's pretty hard to do. But if we test it as a unit, not touching databases, not testing other services, then we can actually achieve this target of 100% code coverage. That's what we want to achieve. But how do you do it? Work. Right? You gotta write testware. There's no way around it. You have to write testware. Stub things out, mock things out. That's what it takes to be able to do true unit testing. But you know what? It's worth the work, because in the end, we end up with this nice foundation of clean code that does precisely what the programmer intended for it to do. No dumb errors, it all works. On that foundation then, we can build our interface testing. Now, I don't mean slam the pieces together and run a functional test. I mean focused testing of our interfaces. So if we are exposing an API, then that means we want to actually test everything that API exposes in every way. And if we're using somebody else's, make sure we're mocking them so we can actually see how our system reacts to it. There it is again, testware. It takes testware to really do a good job of testing these interfaces. And yet, when we do, now we add to our foundation of clean code, a foundation of clean interfaces. Code, interfaces, great technology as a foundation for the next layer of our pyramid, being our functional testing. But really, what we want to do at this point is avoid testing functionality through the graphical user interface. We want to expose our functionality through APIs, 100% of it, so that we can do our functional testing without the complexity of the graphical user interface. So that allows us then to verify, fully verify all the functionality of the application, make sure it all works right. So when we now have a solid application, the code's right, the interfaces are right, the functionality is right. Now we put on top of that the GUI testing. And this means we can actually focus on testing the GUI. Does every widget do what it needs to do? Is it interfacing with our functionality the way it's supposed to work? And what we end up with then is a fully tested application. Absolutely everything is verified, everything's working right, and oh, wait a minute, that's the foundation for what? What's at the top? Manual testing. The reality is some of the tests we need to do are going to be manual tests, things that people's eyes have to look at, things like usability and things like that. And that, of course, needs to be built on foundation of a solid, well-functioning system. Now, the horizontal axis that you see there indicates what we expect as far as the number of test cases it's going to take. If we're going to do 100% code coverage, that's going to require a lot of test cases. At the next level, for the interface testing, probably not quite so many, but really, most of our interfaces, the interface contracts can be pretty complex. That's going to be a lot of test cases. Move up to the functionality, of course, unless your application does very little, there's a fair number of tests we expect we're going to have there. Probably not as much as for the technical testing, but still quite a bit. And of course, for the GUI, well, that really does depend on how complex your GUI is, but we expect it's probably not as many test cases as for the functionality. And finally, the manual testing, we want as few test cases there as possible. I mean, after all, it's time consuming. We just don't want to be putting our time there. Now, the last thing about the pyramid is the vertical dimension on the pyramid. At the bottom of the pyramid, we see tests that are relatively simple and straightforward, especially at the unit testing level. Very simple and straightforward, which means they're easy to write, easy to maintain, easy to take care of, they're not likely to break. But then as you move up the pyramid, the tests become increasingly more complex, which means they're more difficult to work with. And of course, along with that comes they run longer, and they're more likely to produce false negatives. In other words, the test doesn't show a problem when there actually is a problem. And so that's why we want to have more tests at the lower end of the pyramid than at the top. So that's the test automation pyramid. As I said, the beginnings of a test architecture that can give us some really good guidance on how to structure our automated testing.